All right, let's go. I'm going to go right down the list right now. Right down the list. Whether you want to do anything with it or not, that's your call. All right, but I'm going to go right down the list here. Just so I feel comfortable by the time you leave, I've given you everything I could. You guys know I'm not after school today, so instead, if you want, email me as many questions as you want as far as I don't understand this number from the review. How about, can you go into more detail with this topic, etc. Okay? Number one up there, indirect proof. There are 5 of them in your packet to review from. That's on you. That's on you. All the answers on Aspen under the homework answer folder, like usual. All right, so that's on there. Please. Everyone always spends so much time on the proofs. There's one on there. I think it's 6 to 8 points. I can't remember exactly. All right. And again, I've given you the worst of the indirect proofs over those 2 days we did them. All right. So if you can handle those, if you can handle the ones on the review sheet, I think you'll be fine. I don't need you to spend so much time on one question out of 17. All right. So once you think you get a good grip of the proofs, go on to something else. Fill in the blank using a word bank. Basically, the intersection of the medians is called the blank. You got to fill it in with the correct term. There's a whole terms down below in the word bank. You're not going to use all of them. All right. Using your 3 triangle inequality theorems. What do I mean by that? Here you go. Here are the 3 we covered this unit. First one. 1, 2, 3, 4, 5, angle 6. You should be able to give me 2 angles that are smaller than angle 2 based off this first theorem that we did. There's 3 total. This first theorem right now is angle 2 is bigger than what here? 5. And angle 2 is also bigger than 6. What theorem am I applying here? What is angle 2? For this triangle, it's exterior, so it's greater than either 2 remote interiors. Perfect. All right, so that's theorem number 1. Theorem number 2. This is just very basic, but name the smallest side. Why is it the smallest side? Theorem number 2, which says in a triangle, smallest side is across from smallest angle. Okay? Am I going to have you do something as basic as that? Absolutely not on an honors level test. What I'm going to have you do is more of take out your review sheet there, review packet, questions 2 and 3. Okay, in your packet, questions 2 and 3 in the review section, where I have multiple triangles, and you guys got to list the sides out from shortest to longest for me. All right, so that's what I'm talking about. This is where this theorem would apply. Okay, so in your packet, towards the end, you guys got all the review questions. Questions 2 and 3 cover what I'm talking about right now. Okay, this is where that theorem would apply. Everyone good there? And the third and final theorem I'm talking about is six, 8. What are possible values for the third side? This is the third theorem I'm referring to. It's got to be anywhere between 2 and 14. Yes, the technique is to add and subtract the sides, but what's the theorem say? Any 2 sides added up must be greater than the third. So everyone see, that is what I'm referring to when I say 3 triangle inequality theorems. Okay? All good there. All right, perfect. Going back, finding points of concurrency on a graph. I'm going to pass back your quizzes here in a second. There was one on the quiz where I had graphed, I think it was a right triangle, and I asked you to find the circumcenter. Be prepared for that again. All right, find the circumcenter where you have to do your perpendicular bisectors, figure out where they intersect. Maybe I'll say find the orthocenter. Where's the orthocenter on a right triangle? Intersection, whatever that point happens to be there. Some of you guys got that confused. You'll see when I pass back the quiz. All right, so I could ask you to find points of concurrency on a graph. Partitions, we all remember that day. Maybe, maybe not. I gave you 2 on your quiz, so I'll pass those back and you can see how you did. Just to let you know, there are no partition questions as far as the review goes. Listen, so if you want to brush up on your partitions, on Aspen, I put a file under Unit 5. That's all partition questions and answers. Okay, so I got your back on that one. You won't find any in the review, but you'll find some on Aspen. Okay. Depending on the triangle, where's the orthocenter located? So we just went over where it was in a right triangle. Anybody, if it's an acute triangle, where's the orthocenter? Somewhere inside. And then if I give you an obtuse triangle, somewhere outside. Okay. I have circumscribe versus inscribed right now. Tell me about the circle. Is that circle circumscribed or inscribed about the triangle? That is circumscribed when it's on the outside, meaning whatever the center of the circle is called the what? Circumcenter, yes, circumcenter. I pull this now. Now where's the circle? Inscribed, so the center of this circle would be called the in-center, all right, in-center, okay? And then one construction. I'm not going any more detail. One construction. And I'm not going to be that sympathetic as far as partial credit goes on that one. You're supposed to do the circumcenter and you give me the in-center. I don't have much sympathy for you. Okay. What about all the steps to doing them? You guys know up on the website under the Regents Review folder, you got all the videos there for you to review. Okay. But one construction out of that packet we did on Friday is coming back on tomorrow. And I'm going to be not sympathetic at all if you don't remember how to do it. Anything you want to ask what I've gone over here? Okay, real quickly. Here's how I would break up your studying. I would break it up into thirds. Okay, I would break this whole unit up into thirds. We've already talked about the first third, which is indirect proofs. Don't spend too much time. Just make sure you're confident. You're ready to go tomorrow. Second third we've talked about as well, and that's your inequality theorems. That's your 3 inequality theorems. Am I going to ask you to write it out? Nope, but make sure you understand what's going on because there's a ton of problems where you have to apply them. And then the final third is points of concurrency and constructing them. Real quickly, what points of concurrency am I talking about? In-center, circumcenter, orthocenter, and how are they formed? What's so special about them? Can I construct them? Those are the 3 questions for each of these 4 here you should be asking yourself. How are they formed? What's so special about it? Can I construct it? Given a triangle. And then somewhere in there, I don't know where I would put it in. Make sure, don't forget about partitions. I'd probably put it in here. In that third, if I had to pick, but don't forget about them. Anything I can answer for you? All right, so let me give back your quizzes. So you can ask any questions you want on those. Okay, anything from the quiz now? Again, going back to what's on the quiz or what's on the test tomorrow. Give me 1 second. Great, you can take a seat. Just give me 1 second to get going here. Finding points of concurrency on the graph. That's what I'm talking about with number 3 from your quiz. Okay, finding points of concurrency. Also, I asked for the circumcenter here. If I asked for the orthocenter as well, could you find that on this graph? Okay, that's what you're going to see tomorrow on the test. Okay, questions 13 and 14. How'd you do on the partition ones? All right, if you made a mistake, don't make the same mistake tomorrow. Okay, because it's just going to be as basic as those two are. And questions 1 and 2 from the quiz are just like the word bank ones where you got to fill in the blank tomorrow. Okay? Any questions there from you guys? Going? Yep. Okay, 3, how to find the circumcenter. First thing I think about circumcenter, you got to know how it's formed. That is the perpendicular bisectors of each side. So what I need to do here is myself graph in the perpendicular bisectors. What type of triangle did I provide you? A right triangle. This is a horizontal line down here. CB is a horizontal line. What's perpendicular to any horizontal line? Vertical line. And bisect means it goes through the middle. So if you take -3 and count over to 1, that's a distance of what? 4? So this line's going to go 2 over from each. Right there at x equals -1. My coordinate was a little bit tougher. Why? Ready? As you guys go from 3 to -4, what's that distance? 3 to -4. 7. So when you cut that in half, that's 3.5. So you're actually going to go in between here. So if you go 3.5, you're right here, in between 0 and -1. So that point right there is the circumcenter. We already found the x-coordinate is 1. The y-coordinate, again, it was halfway in between 0 and -1, so it had to be -1/2 or -0.5. Okay? You had the distance of 7. The bisector's got to be at 3.5 away from each. Other questions? Okay, you guys got to get after it right now. All right? I'll let you work with other people, but choose your poison. All right, because if you know you're just going to socialize, you may just want to stay by yourself. All right, you have the questions in the packet. You have textbook questions to try. You have the partition questions I popped on Aspen. All right, plenty of stuff to get going here. Figure out a way here. Let's go.